Question number 4 says create a graph to represent the number of candies in the machine compared to the number of customers. So in order to do a graph, the very first thing you want to do is label your axes. Again, we have our x-axis, we have our y-axis. If you take a look at your table back in question number 2, our independent variable, which is on the x-axis, we represent it as a number of customers. So let's label that. This is the number of customers. And we labeled our number of customers as C. And then for our y-axis, our dependent variable, we labeled as the number of pieces of candy. So we had number of candy. And our number of candy, we said this was P of C. Now, the next thing we need to do for our graph is we need to come up with a scale. So if we take a look at the table again from our question number 2, we started at 0 and we went up to about 6 in our table. We could continue to go on, but we had about 6 to represent what we needed. So let's label. We can go up by ones again. So we have 1, 2, 3, 4, 5, and 6. And if you take a look at your y-axis, we start at 2,700, and we gradually go down by 7 each time, where our lowest number we have in our table comes from 6 customers, which is 2,658. So that lowest number, that 2,658, we don't necessarily want to climb all the way up to 2,658. I mean, if you think about how many spaces we have on our graph here, to get all the way up to 2,658 would take us a while. If we went and counted by like 500 or whatever, then again, we just have these small changes of 7 inside. So instead, what we can do is something where we call breaking a graph. So we have to have our scale be consistent, but we could show that we've broken our graph from 0 to a certain number, and then we can go up by a smaller amount than we want to. So this is what it will look like. So if we break our graph, it's one of those, it's kind of a zigzag that shows that we're breaking our graph, which means we're not being consistent in how much we're going up right here. And then what we can do is we can start our very first tick mark at 2,000. I'm going to go with 2,650. And again, you could do whatever you want here. So 2,650 is going to represent for me this very first tick mark. So all these numbers in here is just saying that we're not putting them in right now. We're kind of breaking that graph and starting at 2,650. And I'm just going to go up by 5s. And I'll label every other one. So then this would be 2,660, 2,670, 2,680, 2,690, and up here at the top would be our 2,700. And then we can go ahead and start plotting our points. The points are coming directly from our table. So our first point was 0, 2,700. So our first point is up here. Our second point was 1 and 2,693. So we're just approximating that. That's about halfway through. Then 2,686. Oops, let's fix that. That should have been on the 1 and not the 2. So 2,693 would be here. And then for 2 customers, it was 2,686. So this is 85. So 86 is right above the 85. 3 would be 2,679. So right before the 80. 4 was 2,672. So almost halfway between 70 and 75. 5 was 2,665. And 6 was 2,658, which is about right here. Okay, so then let's take a look at the follow-up questions. Letter A says, how is the graph similar to other graphs of arithmetic sequences? And so it's similar in a way that it is still a straight line. So the points form a straight line. How is the graph different than Scott's workout? So if we look back at Scott's workout or growing dots, what you should remember is that we were adding, we had that common difference that was going up, so our line was going up. In this case, our line is going down or decreasing. So this graph, the line is decreasing, where in Scott's workout, the line was increasing. And then finally, letter C is going to ask us, what is the slope of our line? So let's take a look at the slope of our line. So remember, slope is our rise over our run. So we have rise over run. So if we take any 2 points, so I'm going to look at this point and this point. What we're doing to get from one point to the next, I'm going down 7 and I'm going right 1. So my rise is -7, my run is 1, and if I simplify that, I get -7 as my slope. And remember, the slope and the common difference are always going to be the same. So here the slope is -7. Also, we talked about the common difference was -7.